Okay, continuing our calculations for step 3, moving over a column. We did our sums of squares column in the previous video. So now we're going to do our degrees of freedom. And we're going to do the same thing. I'm going to do the stage 1 calculations, and then I'll follow it with the stage 2 calculations. So starting with our degrees of freedom between treatments, we know that's k minus 1. So in this case, we know the value of k is 3. So our degrees of freedom between treatments is 2. Now, you'll notice that what I put on the formula sheet here is different on this side than it was on the original side. What I'd written on the original side for the independent measures was that it was the summation of the degrees of freedom for each group. What I wrote on the back side is it's the summation of little n minus 1. Well, that is the formula for degrees of freedom, right? Many years ago when I first started teaching this class, my students were split. Some liked it this way, written out that way, and some liked it the second way. And so what I did is I put it one way on one side of the sheet and the other way on the other side of the sheet, trying to make everybody happy, and of course I made nobody happy. So deal with it. That's all I can tell you. But it's the same thing twice. It doesn't really matter, right? How we do that, which way we write it down. So if you don't like it, just flip the sheet over and look at the other one. But same difference here. So our degrees of freedom, there are 5 participants in each treatment condition. So the degrees of freedom for the first treatment condition is 5 minus 1, which is 4, plus 5 minus 1, which is 4, plus 5 minus 1, which is 4. So 4, 8, 12. Our degrees of freedom within treatments equals 12. Again, this tells us the same thing that it did last chapter. Our degrees of freedom total had better work out to be 14 points when we compute it, or we've done something wrong. So, degrees of freedom for the total study, capital N minus 1. We know capital N is 15. 15 minus 1 is indeed 14. So those are all the stage 1 calculations. Now we can do the stage 2 calculations, figure out our degrees of freedom associated with individual differences or between subjects, and subtract it out. So our degrees of freedom between subjects is simply our regular old degrees of freedom formula. Again, all these numbers have to be the same because it's repeated measures. We can't have different values here. So our degrees of freedom between subjects is 4 points. That leaves us to get our degrees of freedom for the residual error for our error term. Degrees of freedom for error is your degrees of freedom within treatments minus your degrees of freedom between subjects. Again, we're literally just going to subtract it out. So in this case, our degrees of freedom for error is 12 minus 4, which equals 8. So now we have our degrees of freedom column finished out. So the next thing for us to do is to get our variance values. Again, we only need 2 in the whole thing. We need to know the variance or mean of squares between treatments, and we need to know the variance or mean of squares for our error term. So we just need those 2 boxes. So our mean of squares or variance between treatments, again, variance is sums of squares between treatments, divided by degrees of freedom between treatments. So our mean of squares between treatments, our sums of squares is off of the thing now, but it was 70. You can see on your own paper, I'm sure. Your degrees of freedom between treatments was 2. So the mean of squares or variance between treatment conditions was 35 points. And now we need to do the same thing for error. Mean of squares for error is sums of squares for error divided by degrees of freedom for error. Our sums of squares for error was 10. Our degrees of freedom for error was 8. So again, this is our second stage calculation. This is error without the individual differences in the denominator. We've calculated them and subtracted them right out. So our mean squares between treatments is 35. Our mean of squares error turns out to be 1.25. So then the last thing to compute, of course, is the F ratio itself. Just like last week, we want this attached to the chart, just right off to the side there, right, sort of at the top. And of course, I don't really have enough room, so I'll have to break it into 2 lines, but you'll get the gist of it. So our F ratio, our numerator for the last 2 weeks has been our mean of squares between treatments. And our denominator is the mean of squares for error, just like last time. Your F ratios are always a ratio or a fraction of 2 different variances. Variance on top, which is treatment effect plus some error, and variance on the bottom is just all error, but in this case without individual differences in it. So our mean of squares between treatments was 35. Our mean of squares for error was 1.25. So our F statistic, or F ratio, again to be more proper, is 28.00, because it's a stat value, right? It's even a whole number, it's got to go all the way out. So here we would say we have an F of 2 and 8 degrees of freedom between treatments, degrees of freedom for error, and it equals 28. Writing this in APA format when we see it in step 4, again, it's going to be the same as what we did. So I'm going to cut this video here, and in the next video, we'll go back and fill out step 2, see what our criteria were, and make our decisions for step 4.